All right, so since we've defined events in terms of a set or subsets, we can also talk about the union and the intersection and the complement of an event. So let's first of all take a look at the union. The union of two events, say E and F, is the set of all outcomes where E or F occur, or both, right? So you can kind of think of it as, let's say we define E, let's say we're drawing a card from a deck of cards, and let's say we define E to be drawing an ace, right? And then F could be drawing a spades. A spades. A spade. And so the union of those two events would be either drawing an ace or drawing a spade, right? Either or, and that would be the union of those two events. Now the intersection of two events is just the set of outcomes where E and F both occur. Okay, so if we use the same example that we were just talking about, then the intersection here of these events would be drawing the ace of spades. Draw the ace of spades. Oops, spade. Right? Because that's the only card that is both a spade and an ace. Okay? And the complement of a set is just all the outcomes where that event does not occur. So if E is drawing, well, I guess we said an ace, right? So if E was drawing an ace, then the complement of E would be drawing not an ace, right? So not drawing an ace. So not drawing an ace. Okay. All right, so let's take a look at example 2 now. Consider the experiment of rolling a die and observing the number that falls uppermost. We're going to let E be the event of rolling an even number. We're going to let O be the event of rolling an odd number. And we're going to let P be the event of rolling a prime number. Okay. So let's define these sets. Okay, so we're going to roll a die, and what are all of the possible outcomes? All right, what's our sample space? Well, that's just all the possible outcomes. So you're either going to roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6, right? So that's our sample space. E is the event of rolling an even number. So what does the event E look like? That would be rolling a 2 or a 4 or a 6, right? So that's how we would define the event E. O is rolling an odd number, right? So that would be a 1 or a 3 or a 5. That would be our odd event. Now primes, okay, prime, this is rolling a prime. P is our prime event. And so what are the possible prime numbers? Well, so first of all, you have to remember 1 is not a prime. 1 has a special status as the multiplicative identity, so it's not a prime number. But 2 and 3 and 5 are prime. Okay? So that's our event P. What is the union of E and P? Okay? So remember, union is or, so we're looking for all of the possible outcomes that are either even or prime. Okay? Even or prime. Well, we're going to have 2 and 3 and 4 and 5 and 6. All of those are either even or prime. Okay? And you can see it's just the union of those two sets. Now 2 is in both sets, so we end up with 5 elements in the set. All right, what is the intersection of O and P? Okay, so this is, O was odd, P was prime. So the intersection of those two sets are all of the outcomes that are both odd and prime. Okay, so remember that intersection is and. So I'm looking for all the outcomes that are odd and prime. So that's just going to be 3 and 5. Okay, because P, or 2 is even, so P complement. So this is the event that we don't get a prime number. So I want all of the outcomes that are not prime. So 1, 4, and 6. Those are all not primes. And what is the intersection of E and O? Okay, so E was all the evens, O was all the odds. So what is the intersection of those two? Well, you can see the two sets, right? They don't have any elements in common, so the intersection is the empty set. Okay? Which brings us to our next definition down here. Mutually exclusive events. Two events, E and F, that cannot occur at the same time are said to be mutually exclusive if their intersection is the empty set. So in our example 2, the even set and the odd set are mutually exclusive. They're mutually exclusive because they can occur at the same time and their intersection is empty. Okay, so if you were to draw that, what that looks like, you have two sets, E and F, and their intersection is empty, right? So they don't intersect. So there's E and F, and this would represent mutually exclusive events. Okay. Now, why do we care about mutually exclusive events? We're going to come to that. But mutually exclusive events are important because they're easy to count. That's kind of the nice thing about mutually exclusive events. So we're going to be talking more about mutually exclusive events. But the next thing we're going to go on to example 3, so I will meet you in the next video.